Okay, thank you, everyone. So welcome to the December 2021 Trees Around the Globe Student Research Campaign webinar. And before we get started with the actual webinar, I want to remind you once again from our folks at Oregon State University, our folks who are running the survey. Basically, they're looking at what your participation is with the three major Globe campaigns: Trees Around the Globe Student Research Campaign, the Globe Mission Mosquito, and the U.S. Air Quality. And please, if you haven't already, go ahead and take this survey. Peder Falcon will post the link again in the chat box for those of you who came in after I posted it prior, because you may not be able to see it. But take a look at that, and it won't take much of your time, only a couple of minutes. But it's great for us to know, what your participation is, your level of interest, and everything is with these campaigns. So once again, thank you for doing that. Our evaluators for the all the campaigns reside at Oregon State University, where our fellow campaign partner Peder Nelson is based at as well. So let's get started with the webinar. So today we are going to be looking at land cover and tree canopy of the Globe Africa region. We're starting our 2 months focus on Globe Africa region. And today we're going to go through some of the land cover information, mapping and everything using those two major online tools. We're going to be doing that with Peder Nelson in just a bit. He's going to be, taking you through, some of these things that, to really spark interest and, spark interest in the research in your local area. When you have these maps of these different countries, all the Globe Africa countries, and we've actually created a resource which we will share it very soon. We're just finalizing it right now. We've actually created a resource with land covers, basically screen grabs from 2019 from the land cover viewer tool of all 126 Globe countries, and that includes, of course, all the ones from the Globe Africa region. And Peder will be showcasing that and some other things in a couple minutes. So with that said, here is our agenda, and we're going to be doing this nice little warm-up activity again. We're going to take about 5 minutes to do this, and this was something we introduced last time, where we give you, two images, and then we ask you to write something in the chat about what you see. And apologize, my phone's ringing in the background. But we have introduction. I'm going to do the introduction and metrics, and then we will have the Globe Africa Regional Alumni Coordinator and Globe Benin Country Coordinator, Ylliass Destin Lawani, who will be, I did an interview with him, and he'll be talking a little bit about, this. And I'm going to play first part of this interview now when we get into this part of the agenda. And then the second part of the interview, I will then play at next one in January, at the next webinar in January. And then what you can do is you can actually go to the website for the campaign and look on the webinar page. And you can look on the webinar page and really watch the entire interview video with Ylliass. So it's really good. It's really great interview, and he really has some great stuff to say about why people in the Globe Africa region should be looking at particular areas in Africa, looking at land cover and trees to really help them understand, him as a researcher as well, help them understand what's going on in, the African countries. And then, as I mentioned earlier, Peder will be coming into highlighting land cover in different areas in Africa. And then Peder Falcon will be looking at NASA Eyes on the Earth and showing you this really cool tool, in relation to, what's happening, potentially in Africa, right now, what has happened in the past. And then we're going to have a little bit of a group discussion, and then I will show you a little teaser video about what's our featured presentation for next month: an unexpectedly large count of trees in the Western African Sahara and Sahel. And then we will adjourn. So that's the agenda right now. So, hope you enjoy this, and let's do first the regional warm-up. This is what we call a Twitter-like writing activity, where here's two images. And once again, this is to get people warmed up, and students and educators to really focus on particular images and trying to identify all the characteristics you see in these images. So what we'd like you to do is to, choose one of these images, choose the one that you think best represents the globe Africa region, okay? And then once you do, in 140 characters or less, give or take, we're not putting this on Twitter right now, but it's to really get you to succinctly, identify the characteristics you see. But in 140 characters or less, write a description of the characteristics you see in the image. So once again, choose which one you think best represents the globe Africa region, and then write a description about what you see. Now, this could be a scientific description. It could be kind of a poetic, artsy type description. It all depends upon what you want to write. But what you want to focus on is identifying these characteristics that you see in this picture, because what's important for understanding, what's happening in that environment. So, please check this out, and we'll give you about 3-4 minutes or so, and please put that info in the chat. And Peter, Falcon, if you see any of those come into the chat, please, feel free to read those off, because I'm sharing my entire screen. I don't see the chat right now. So if you like, take a couple minutes to do that. And as I mentioned, it's really to help you focus on, an image and basically what you're seeing in that image, because that really helps us understand what's happening in a local environment when you're taking an observation. And when you're trying to ask and answer scientific research questions.
Well, we got one response so far. Anna says the photo on the right of the savanna with some trees. So she feels that looks more like Africa.
Okay.
And we have another response, the one on the right with the acai, and the savanna.
Excellent. Yeah, I kind of made it a little obvious here with the two images in the globe Africa region. The last month was a little tricky. They could have potentially both been part of the Asia Pacific region last time, but one was, definitely a little more favorable.
Mm-hmm. Dorian has a response as well. She says, with the seasonal changes being snow to some parts of the world, while other regions remain hot and dry.
Ah, that's great.
Hello? Hello?
Yes, hi.
Hello? Hi.
We can hear you.
Picture.
Do you have a response?
Yeah, picture B represents region, Africa region.
Excellent. So the second photo should be. Yes, we hear you, Bobby.
Yeah.
Okay.
I'm saying that,
thank you for that response.
The picture B, yes, at where I am, the picture B represents the Africa region.
Excellent.
So far, everyone feels like the second photo is more Africa, Brian. So we got another response from Mohammed. He says, I think the left one is the Arctic region, and the one on the right is the Africa region.
Excellent. Yeah, the left one. The left one was actually taken. It's actually a globe observer image from Alaska.
I don't remember. But we know Africa is so large that it could have. It's so diverse. I mean, it could really be anywhere. That tree.
All right, so let's go ahead and move on. It seems like most people, chose the right image, and I'm not going to say, you're most likely right? But I like to just hear, different viewpoints, and that's great. So yeah, so this was, actually taken, in Africa. This is a stock image from Google. This isn't a Globe Observer, observation image on the right. But what you see here is you see this a huge difference between, and as Dorian mentioned, you can tell the climate is completely different in both of these locations. You have this, this cold, cold frozen, tundra or whatever it is, in this location on the left, and then we have this, this area, could be savanna, with the acai tree, and you can see a little bit of barren rock there, I believe, and it's, to me, both of them look pretty inhospitable, you know, for humans in general, you know, but there, of course, there are creatures and critters out there that do live in these locations, but they don't look like the one might be extremely cold and another one looks extremely warm. So, you know, I love you know, the diversity in all the responses here. That's great. And, you know, some of these responses that, you know, even though we are in right now, everyone in part of this campaign is in a different part of the world, we're able to all look at this same image and help identify, you know, what they're seeing in this image and which one, you know, looks more like the Globe Africa region. So, you know, that's, we're really getting into what we really want to do, you know, for these warm-up activities. So let's go ahead and move forward. So once again, here's our campaign team. I show this at every webinar. Quickly, through some metrics again, I'll direct you all the way to the last two entries on the bottom in the rectangle. Year 4, which began October 1st, 2021 through present, which is today, December 7th, 2021. We have over 3,300 tree height measurements at over 1,000 global sites. We have over 1,000 land cover observations from 564 global sites, and over 2,300 greenings measurements, green up, green down, from 190 global sites. And the majority of those, as you know, come from the folks at the European Phenology Campaign, which they just finished their fall green down campaign as part of the European Phenology Campaign. So, you know, thank you for all those observations coming in. And for the full campaign, which began, as you know, September 15, 2018, with the launch of the ICESat-2 satellite, Ice Cloud and Land Elevation 2 satellite, we have over 93,000, almost 94,000 measurements from over 34,700 global sites. So that's a lot of data coming in. And here is a map from the GlobeViz page, the visualization tool. This is showing you these 93,913 measurements. It doesn't look like it, but you know, if you zoom down, you know, it starts spreading out and you get more numbers. We've had, this is actually the 40th official campaign webinar today. We've had 8 special webinars. We've actually had a couple other, you know, associated ones where, you know, our team has presented at the European Phenology Campaign, at the Urban Heat Island Effect Surface Temperature Field Campaign, and Globe Mission Mosquito. So I don't have all those included in here, but some of those 8 special ones are ones like a workshop, that 5-hour workshop we did last year, actually earlier this year in the spring, but was part of year 3 of the campaign. We have participants from 58 countries who are active in the campaign. And as you know, and if you may have visited these on the campaign website, we have 41 blogs with almost 130,000 views. So we have a lot of good information out there, from data to blogs to, you know, recorded webinars, archived webinars and information, links and everything like that to help you, you know, in your research, learn more about the campaign and so on. So that's such a weird screenshot right there. It looks like I'm falling, like I'm asleep or something, but that's where it started. But what I'm going to do is I'm going to play the interview, and you won't see Ylliass because he was having connection issues. He is based in Benin, but he was actually in Gambia on assignment when I did the interview with him, and the connection, there were some connection issues where he was. So he had to turn his screen off to decrease the bandwidth so it wouldn't be an issue with him discussing. So once in a while, you may hear a little stutter in his voice as far as the choppiness from the connection on his end. So, but this is the first half of the interview, and this is to get people really excited about, you know, why the Globe Africa region is so important when looking at trees and land cover. So let me go ahead and start this video for you. And then as you see, this is, you know, a couple minutes, about 6 minutes long, but I want to show you this, and then the other half we will show at the January webinar. Welcome to the Trees Around the Globe Student Research Campaign Year 4 interviews. My name is Brian Campbell, and I am the lead for the campaign. And today we have a special guest to talk to you about the Globe Africa region. Would you please introduce yourself and your position within the Globe program?
Thank you very much, Brian. My name is Ylliass Destin Lawani. I'm the country coordinator of Benin, but I'm at the regional office, the Africa Regional Coordinator of Alumni Africa Regional Coordinator.
welcome. Thank you so much for being here today and, discussing with us a little bit about the importance of taking tree height and land cover observations in the Globe Africa region and sharing it with the rest of the Globe community. So why is it important for Globe participants in the Globe Africa region to be part of the Trees Around the Globe student research campaign?
Brian, this is a very, very interesting question. Africa is seen like a continent, part of the world which is not giving some additional contribution to the community. And I think that this project, this campaign, helped Africa to gather some interesting data about trees and also about all other components. By taking trees data, they can use some other protocols like land cover, like the biosphere around the trees. Can use also a mosquito protocol. So I think that it is important to have in a certain period, a big big number of data from Africa. So it is very important for us in Africa to participate in this campaign, which which is very important for our research. And our contribution should be very interesting to contribute more to the continent, to the research at the international level.
Yeah, that's great, and I'm really excited that you mentioned like the mosquito, habitat mapper, which the mosquito observation for the GLOBE program, because that's one thing we're really focusing on this year with the Trees campaign is how we can work with the other campaigns and observations like Globe Mission Mosquito and Service Temperature Field Campaign and air quality, but especially the Mission Mosquito, which is plays such a huge role in the African environment, taking these observations. And that's one thing that we're really working on is to do these multi-campaign, webinars and collaboration. So, thank you for mentioning that. So, do you recommend students and teachers in the Globe Africa region work with both the GLOBE data for land cover and tree height, as well as satellite data? Why is the comparison of the data from GLOBE program and satellite data important?
Yeah, the comparison is very important. You, Brian, you may remember that I started GLOBE when I was student. So it was in 1998. And since that time, it was very crucial for our government and for our teachers and parents, because all these are the same community. It was important to compare the data which are taken from the space with the one which are taken from the ground to have a better accuracy of the data. So it is for me, it is important, and I would recommend strongly to the students, teachers, researchers, and the science community of the continent to be part of the campaign and the other related campaign in order to get accurate data. Okay. Also for the mosquito, as we mentioned it, for the mosquito protocol, as you see on the ground, we have surface, water on the surface. Okay, and with the satellite from the space, we take data from the space. So it is important by doing this correlation to get data which can be used for research. And Africa needs a certain amount of data. For the last COP, you may recall that the president and the head of state have mentioned the importance to have data for our continent, because in the research there is a lack of data for Africa continent, and it is due to the priority. People, our government has many other issues that they want to face than research. But today, as how climate change are affecting the life of people, so it is important and crucial for us in our different countries to participate in data collection. And the better way is to do it is to include and to involve students, teachers, and researchers, especially students in the school, because they have a future and they can work continuously to gather a certain number, a big number, a big amount, a certain number of data. Yeah.
Yes,
so I would greatly recommend.
Excellent, thank you. Yeah, that's super important. You know, when you mention that, you know, the head of state, you know, wants to say, hey, you know, there's a lack of data. We need the data, and the GLOBE program, Trees Around the Globe Student Research Campaign, Mission Mosquito. These are all such vital projects and programs to get that data, you know, in the hands of people who are going to use that in the real world. Oh, sorry, that was the end of the video. And then it goes to the next question. So yeah, so that was the first part of the interview with Ylliass Destin Lawani, the Globe Africa Regional Alumni Coordinator and the Globe Benin Country Coordinator. So stay tuned for more of that. And as I mentioned, we're on the webinar page for our campaign. You can go on and check out the full interview there. And I'll be playing the back half of this interview at the January webinar. Welcome to, okay, so what I'm going to do now is I'm going to pass it over to Peder Nelson so we can talk a little bit about, you know, land cover in Globe Africa. And I just threw this graphic up here as just examples of the things that we have put together on this tool that we're going to, I should say, on this resource that we're going to, you know, share with you the link to it sometime. We have to break it up into the 6 globe regions first, but after we have to finish getting the information up here. So this is just showing you examples of, you know, pretty drastically different locations from Benin, Gabon, Gambia, and Liberia in Africa. So Peder Nelson, let me pass it over to you. And would you like me to stop showing my screen or stay here for some time?
Yeah, actually, Brian, let's just stay here for a moment. How about this? I can actually talk into my microphone now. So thank you all. I'm really excited to be, you know, here to talk about maps and data, and you know, in particular about, you know, what is actually happening and what are the resources in the distribution of trees around the globe. This, I think, is to me an exciting time that our campaign and research is entering into. And that is this global map that we're presenting here today. This is a way that we can start to understand the distribution of trees around the globe. And what Brian has right here, I think, is a great example of, I think, 2 important concepts. One is that how trees are arranged on the landscape is very different. And what we see in when we look at the map in Benin, for instance, in the upper left, we see in areas where there are sometimes green areas that are big patches. And then there's some other purple colors, yellow colors, other colors around like that. So that's a really interesting pattern that I have all kinds of questions about. Why does it look that way? In contrast to, it looks like both Gabon and Liberia, which appear to be much more continuous green. And so, you know, I just kind of have that question. Why do these countries have different arrangements of these green colors? And what does that mean? Because when I look at Gambia, the country of Gambia there, one thing I noticed is just kind of this strange shape, right? It has some flat lines, and then it looks like it follows a river and sort of has been buffered and actually sort of follows the shape of the river. Very interesting outlines. So, you know, I think one of the important things that is important when we start calculating how much trees are in a country is the different shapes of these countries and that are all around us, and thinking about why do they have those shapes. Because sometimes when we actually start looking at our maps, It is people, it is how they arrange themselves. It is the history of these locations that help us to understand the shapes and locations of our trees, or in this case, the green on our landscapes. So, I want to encourage you to, use the tools that we're providing to you to explore the patterns and start thinking about maybe the processes that are occurring in these different locations around the world, or the globe, if you will. So, this is a big piece that I think the GLOBE program can really foster, is helping us to become global citizens and really understand why things look the way that they do in the world around us, not only locally, but also globally. So, we want to highlight that because we don't know how many people are actually going to these maps and are actually exploring them, are coming up with questions based off of these. So I am going to take control of the desktop at this point. And I want to highlight a really important tool that I encourage everybody to use. And this is the map cube that My NASA Data has put out. And this is really important because the more systematic way we can start looking at our data, the easier it is to actually understand the processes. But I also want to highlight the errors that might be occurring in these maps. Now, remember that what we're showing you are predictions at a location. It doesn't mean that that is the truth. That is actually part of one of the investigations that we encourage you to take on, is not only looking at and examining these maps or data sets, but also really putting them into context of what you know or what is occurring in that location. So you should always examine the map that is there. The first thing, orient yourself. Right? So, I find it always interesting that when I go to the globe visualization system, it tends to focus right on the United States for me. So, that's one of the first things that we need to do, is actually orient ourselves to our region of interest. And I want to highlight one thing that is really important when you look at these maps is that there is some stretching and some distortion that does occur with a web map. So pay attention to this when you're looking, so that you don't end up being misled by what you find on a map. I think one of the things that's important is to recognize that the southern tip of South Africa here is at about 45 degrees south, which is not as far south as what a lot of people think it is. And so I just kind of want to highlight that location. And so if you'll notice that when we're looking at the southern tip of South Africa, we're very close to kind of the middle of South America, and kind of more in the middle of Argentina. So those are really important things to keep in mind when we are actually looking at a location. Okay, so examine the map. What is there? What is the person trying to actually show you? So one thing that I want to do just immediately is I want to pull up a little bit of the globe data and see if we look at our tree heights, for instance, where are we actually getting them? So one thing I want to highlight when I zoom in here, at least for the last year, we're getting some data coming in, but there's a lot of locations that are missing data. And so how do we make sense out of that? I always find this one really interesting. This location right here. So this tends to be our 0, latitude, longitude. And if we zoom in, one thing that we might notice is that there's this location that is off on the coast. And so this is the kind of errors that you might find. And I just want to highlight this because it's really important and tends to occur when you're looking at off the coast of Africa here, that we tend to have 0 values. Just something interesting that always tends to pop up when you start looking at Africa. And so, here, what I want to highlight is we're getting some data coming from the north and in the middle of the continent and towards the southern part of the continent. I want to highlight, if we look at this one, it's coming from a Canadian citizen scientist. And here we apparently have a building that's there. And so, that location and one data point always leads us to questions of, is that right? Or is that reasonable? Is that to be expected for that location? So I wanna highlight that we can always turn on the satellite base map. And this is really interesting because when we start thinking about our trees around the globe, something really obvious comes out when we start looking at Africa. And that is, there is this sort of line where we don't have trees or vegetation to the north. And this is the Sahara Desert, an area that is, not very well vegetated or treed. And this is the area that we'll be hearing a lot more about next year in our next webinar, which will be next year. Because actually documenting the trees as we transition from the desert into more of the tropical forested areas is a really important aspect that NASA and researchers have been focusing on. And that's because as we zoom in, we have this transition zone where we have a sparse or very few trees, for a variety of reasons. And then we start transitioning as we get closer to the equator into areas where we have more green, right? So as we come down, one of the things that we should start looking at and start thinking about is where on Earth are we? And so our latitude, longitude are really important numbers. One of the other important numbers is elevation, right? So keeping track of that latitude, longitude, and elevation can help us to understand maybe why we're seeing the white on this map. They could be clouds. They could actually be snow or glaciers, right? So, keeping track of examining the map for colors, patterns, textures, knowing where we are in the world and what things to expect are really important. Are there any questions that might be coming out of looking at a map like this? And I hope that you do start to see some patterns or questions that might be coming up when you're even looking at this level of vegetation. And one thing that I'd like to kind of to point out that you should be seeing is as we zoom in and get a little bit closer, you start to see transitions between green areas and brown areas. And you should start to see these sort of lines or linear features. And in certain places, it's really obvious why those linear features might be there. Other cases, it may not be. So again, the closer we zoom in, the more detail that we can get, the more we can maybe start to understand these patterns and textures that are there. And what becomes really obvious is sometimes you get a different base map. But what becomes really obvious is you can start to see how people are managing landscapes. And this is very similar to when we were looking in Southeast Asia and in India last time. You start to see these patterns. Sometimes they are rectangular, sometimes they're more of a polygon shape, but you get these geometric patterns on the landscape. And that almost always tells us that people are doing something here. Now, what I find interesting is that you can tell something about the trees in an area because of these edges when you start looking at landscapes from space. And so you can see edges. Sometimes you can see the shadows from the height of those trees. Sometimes you can actually see the patterns of farming, of actually putting those trees in order. So again, we're looking for interesting patterns. The other thing that I want to highlight is that a lot of times you might see this reddish color. Sometimes that can actually be from the soil. But in other cases, what is actually happening is that after trees are cut down, in order to prepare the soil for planting new trees, you'll actually burn the area. And so this is a common practice that is occurring not only in Africa, but also in places across North America, in South America, pretty much anywhere where you have trees and people are managing them, you'll end up having this charcoal residue that ends up on the surface. So again, colors and textures help me to see some interesting patterns that make me come up with questions that hopefully Globe can help me answer. So one of the things that you should also notice when you're looking at trees around the globe, I want to highlight this, is you'll have areas that are protected. And we can tell that they're protected because of these edges. You see where it's a lighter, brighter green, and then we end up with the darker green in this area. And what we're seeing with this darker green is not only more leaf area from these trees, but we're also seeing the shadows that come in from the trees as they grow and are casting shadow from the height and the bulk of their tree canopy. So we are able to notice these patterns, and we can document these patterns from space. And one of the things that you should see is when a lot of times when you see this big patch, and then it typically has a tail that goes along with it. And one of the things that we know about these sort of shapes like this is that if we zoom in, there you will almost always find a riparian area or a water that is being protected. Okay, so these are some really obvious features that come out. And when I'm looking across the globe Africa region, there are these typical patterns that come out of managed areas, protected areas, and that relationship between our natural areas and our built up areas. And sometimes they become really obvious, like when we're looking at areas like this, right? So again, I don't have as much experience. I've never actually been to Africa, let alone to this particular area. So I am relying on the globe visualization system and that data to help me to understand what I'm seeing. And as we can see here, we're missing a lot of that information. So I want to quickly, alert you again to one of the places that you can get a lot of information. And I think one of the most important ones is looking at cloud cover. Where do you have cloud cover? Where do you not have cloud cover? One of the things that we do notice when we're looking at Africa in particular is that there is this equatorial area that tends to have a lot of cloud cover, and it tends to burn a lot. And so it has smoke in the sky, and it also has a lot of white clouds like this that make it really hard to make those measurements from space. And so this again is where we really need that ground data to help us to track what is happening underneath these clouds. So it's exciting that you can actually start to look at these dynamics. And there's a lot of NASA videos that show how the vegetation dynamics, or in particular the dust that is coming from Africa, actually ends up impacting the cloud formation and the rainfall of the Amazonia area, but also the hurricanes that end up impacting North America here. So as we think about and engage with what's happening in Africa, we do want to recognize that we have these connections that connect all of us in the globe together. I think it's really important, you know, when we flip over and we can focus on just the trees. Again, you know, here is our global tree height estimation, or our model. And I think what really comes out when we look at this data is the transition zones, right? From the areas where we have very little trees in Africa, in the northern area, to the transition zones. As you start to get vegetation and trees, you start to then get to the heart of the other part of the lungs of our planet. Here in this equatorial area of the Democratic Republic of Congo, and Gabon, and many of the other areas that many of us hear about needing protection, or where the gorillas might be living, or other big charismatic things like that we typically hear about. What is fascinating to me as I zoom in on this data layer is you start to actually see some of the effects of clouds, but also the effects of sometimes human choices. And this is really fascinating, how we actually have areas that are sort of untreed in between areas that are treed, that are primarily along river systems, right? These linear features, again, if we follow them along, we'll find that they are rivers. So, you know, even though there might be big patches of trees in some areas, we can actually see how there are environmental characteristics that are fostering tree growth in these areas. And when we zoom in, it's really pretty fascinating to see how tied together the tree height is to these river areas. And again, we can come in and turn off that, and let's just kind of fade that back a little bit. And really fascinating patterns. And here we can really see the floodplain and the way that the river is really tied to this green vegetation in this area. This is the kind of river type of pattern that we see in the southwest of the North America, or in some areas in South America in particular as we head further south, right? Really fascinating patterns that we see with these sort of trees. And you can see that in this area, it is really highly tied to those riparian and vegetated areas. I thought Gabon was sort of the contrasting area, where if we turn on and turn our tree height back on, what we see is vast forest, right? Unbroken in many ways. And so when we zoom in, all we see is the top of trees and this really high green pattern. And so just very different conditions. And so, you know, it's really fascinating, especially to go and spend some time looking at that tree height. Where are the tallest trees occurring on this landscape, and where are they not? And remember, we can actually go over here, and I'm going to increase our tree height and look at ones that are some of the tallest, just, you know, for a little bit of contrast. And, you know, when we do that, one thing that you should notice is that we lose a lot of those lower trees that we're looking at over here in the riparian area. But when we look over at the country of Gabon, you notice that almost all of those trees are over 19 meters in height. And so we tend to have a pretty contiguous forest. And it took at least 19 years or longer for those trees to actually get to that height, right? If we just base or use a very general meter growth per year, it's at least 19 years to be able to get a vegetation like this. So, you know, I really encourage you to spend a little bit of time looking around and trying to find and understand why do we have the tree height that we do in the locations that we do across the African continent. And again, you know, sometimes it is due to people's choices. Deforestation is a huge issue here. And it's tied to the biomass burning, which then impacts people's air quality and their the air quality that they have to breathe and to live with. And so, you know, it is very much the same sort of issues and concerns that we were talking about when we're looking at Asia and the South Pacific areas. Different types of forests, maybe different types of trees, but many of the same issues are happening and occurring there. And, you know, again, when we look at our land cover, it becomes really obvious these transition zones where it's bare, sparse vegetation, and it transitions into these grasslands, which then transition into the forested areas. So again, there is this successional pattern that is happening that we're documenting with our land cover. And so as we, you know, think about our own landscapes, think about the grasslands that we have today, and will they at some point transition into a forest, right? This is an important thing, that when we're talking about forests, we are talking about something that takes a while for them to establish. And so usually they are starting off in a grassland or shrub area that transitions into a treed landscape. And this area just demonstrates this better than almost anywhere else in the world, this transition zone from bare to grass to shrub to trees. And so I hope that, you know, going through this, you've been able to practice a little bit on your map questions, how to read a map, going through examining where on earth are we, summarizing what we might see, analyzing that map for further questions, thinking about the data and how it was collected and maybe the limitations, like I was showing you the clouds. And then what sort of question can you ask about this map? So I noticed that there was some chat questions happening in the chat right now, but I wanted to make sure that we had a good chance to spend some time on the African continent and looking at some of the interesting patterns that are happening there while we're going through, and really thinking about the similarities, but maybe the differences that are occurring in Africa, from the equatorial areas to you know, the further off areas like that, the southern tip of the South African coast there. So with that, I'll pass back to Peter and Brian, and hope that people had at least a chance to get a little deeper insight into the patterns and processes that are happening at a big scale across Africa.
All right, thank you, Peter. So yeah, great. So does anybody have any questions for Peter and what he was just talking about? And you know, the details that Peter went into are, are details that, those visual details are ones that, we really want to, take a look at, when you're doing this research or when your students are doing this research. Okay, we have a hand up. Mike, go ahead.
So Peter, I apologize if I'm phrasing this question the wrong way, but are the JEDI data normalized across regions? So if I look at a change in land cover in Africa, am I using the same metric as if I looked across South America or North America?
Yes. So there is structural differences in those different forest types. And so the way that the laser will reflect that light back off will be kind of different. But overall, the same process is used to look at that wave and the structure of that wave that's coming back, that's what you can see in open altimetry. And when you look at the different locations, you'll see that they will all reflect the light in kind of the same way at about the top of the canopy. And then things will kind of get bounced around as it goes into the structure of the forest. And that's where we get some interesting, sometimes bad results, but sometimes the really interesting things that are happening. It's where you can see that all of the trees are, or all of the leaf is in the very top of the tree canopy. You know, in some of these African forests, compared to here in Oregon, where some of our canopy is actually lower to the canopy floor, and so it's a little lower there. So it is basically the same process, and we see this in our Landsat data in the imagery that we're seeing that shadow. It is actually part of that signal that we're seeing in there. It's why it's a darker color within there. And so that characteristic is the same around the world. Older forests have more shadow and therefore are a little bit darker. They're not even as green as like the grass behind you because of all of that light that's getting bounced around in the structure of that forest. Now, you know, when you try to make a model to predict that tree height, that's where you do need that local calibration, those local measurements, because we do find that is where our models have broken down, and we've overestimated tree height or underestimated. So one of the things that you see with the global forest canopy height data we're highlighting here, it can only predict up to 30-meter tall trees. Now, we know that's only about 90 feet tall. Here in Oregon, we have trees that are definitely taller than 90 feet. And I'm pretty sure that, you know, when we start looking around, that's kind of that max height. And that is a limitation of the way that the light gets reflected off. We also don't have many forests that are at that height consistently. So you'll typically have one tree like height kind of sticking up. And so what we're actually showing here is the height at 98% of all the trees. So not the total tallest tree, but about where 98% of the tree canopy is located. So that relative height is an important characteristic, that it's not the total tallest trees, but there's kind of like the top of most of the canopy there. The nice thing is, Mike, is that it is a consistent metric that we can use around the globe. And so if you start looking at these, this is a great experiment. You have a prediction from this global forest height of what it should be in your location, and you can then go there and actually make your own measurements and see, do they match? Do they not match? How far off are they? I want to highlight that one thing that, you know, if we were trying to average like the trees behind you, you have to take into account the zero that is all around there that is not tree canopy height, right? So when you are actually looking at these locations, you also need to incorporate that zero of not tree canopy height in there. So it's an important metric that is important, but you have to think about the size of the scale that these are getting measured on, which is a 30-meter pixel, 30 meters by 30 meters, and all of the trees that are in that area, or no trees. So that is where you end up with something being a lot less tall than what you expect, because you have to average all of that together. So this is a really good question, Mike, because one thing you'll see is we're highlighting the JEDI data. That only goes from 50 degrees south to 50 degrees north. So if you're in Canada or in one of the northern latitudes, this data doesn't work as well for you. And that's where we have to switch to the ISAT-2 data. So this compromise and what data do we use? What data do we works for my area? This is a constant question and trade-off that scientists are trying to get around. So let us know if you're working in an area and you need some data, or you're wondering about how it's put together. Because especially when you move to less treed areas, the data might become less robust, and why you're finding errors might be, we might be able to fill you in on some reasons why you might be getting the results that you are. So yeah, so Mike, until we got the lasers in space, we had been relying on Landsat to give us that height. And that was we were only able to get about 68% correct with that. With the lasers, we were able to add about 20% more accuracy to our height estimates with that by bringing in that structural piece. So it was a really big step forward that hopefully some people are taking advantage of and are testing out this model that we're highlighting compared to what they're actually seeing on the ground.
Thanks.
And yes, Mohammed, please use the JEDI data. And this is something that Brian and I haven't highlighted because it is just brought into the open altimetry site. It's still sort of in experimental version, but the data is there. And so that is something that we can highlight, and Brian has highlighted in the past, how to look at the waveform or the LiDAR wave as it goes through a particular location or pixel, so that not only do you get the maps like we're showing you, but you can get that 3D structure of those trees or of that forest for a location. So yeah, that's one that we can go into a little bit more detail as well. But I'm sure, Brian, you've done a video recording on how to work with open altimetry.
Yep. And while you answered Mohammed, who's also actually coming to us from Bangladesh right now,
Nice.
he asked on here. Let me go. He says deforestation are a result of trees used for burning for cooking. Can we trace them?
Ooh, yes, that's a great one. And so Mohammed, this actually was brought up in the country of Georgia, which is a brand new, relatively new GLOBE partner, GLOBE country, I mean. And there was some colleagues of mine who were actually tracking deforestation from 1 or 2 trees being removed for firewood building. And this is exactly one of those things that if you just looked at one date, you may not see that. But if you look at that location over 20 years, you will slowly see the greenness of that location go down over time as you remove that one tree and then cut it up and use it for your wood burning. And so it's one of those pieces that a lot of times scientists like me might throw that out, because we don't have the reference data. We don't have confidence that that is real, that is real change. And so if you're able to record those locations and put them into the GLOBE database, for instance, then when a scientist like me or students are working on a project and they see, well, I see this decrease in greenness or decrease in shadow from trees coming down, I know that that's actually real and that it wasn't atmospheric correction or some of these other errors that we have to account for. And it really goes back that we don't know that that's actually happening in a location. That is the reason why they're not in a model like this. So that's a really great example of how that local knowledge can unravel that data problem that scientists have of just not knowing. We see a signal, but we don't know why it's occurring. And I'll say, we have been able to document 1, 2, 3 trees being struck by lightning. And we actually saw that in a single Landsat pixel. So it's pretty astonishing when you start looking at these changes over time, especially over long periods of time, how you can see those subtle transitions from 1 tree to 4 trees, or from 4 trees to 1 tree over time. But it all goes back to knowing what you're looking for And that's when you can have confidence that what you're seeing is real change and not false change. And that's the big question. Yeah, so Mohammed, hopefully that gives you, some confidence that we can see some of these things, but we need that insight that you might be able to provide to us.
Thank you.
Yeah, and that Bangladesh area in particular is really challenging in the same way that I was kind of highlighting here. Cloud cover is the first challenge. And then the second one is you end up with flooded vegetation in some cases, right? And so tracking that flooding of the vegetation is an important one as well. And the timing of when the floods come and the impacts on them are really important. And one particular tree or group of trees that we didn't highlight here, but we have in the past, is the mangroves that are really in that transition zone between the ocean and land. And one of the things that some NASA researchers have found is that hurricanes are the big predictor of how tall those trees are going to be. And so there are 40-meter tall trees along the coast of Africa because that is the origination or sort of the place where hurricanes start, not where they end. And so imagine 40-meter tall trees along this coastal area. And that's all because they don't have a hurricane coming through and disturbing them in the way that other places are, sort of getting that wind impact in particular. That is really taking those trees from being tall to being about 10 meters or less. So it's just really fascinating how the trees really do tell us a lot about those landscapes. And so I wanted to highlight that because it's a really fascinating one of when we know what we're looking for, we can understand that story. And it's when we don't know what we're looking for, like I do a lot of times, that we end up missing the pixels, or we miss the story, or we underestimate the amount of change or carbon that's out there. And so, yeah, this is a big reason why Brian and I have brought these science data sets to us, to our group this year, is to help us to see where is it right and where is it sort of right and where is it completely right. Where did we get this in a place where we can actually start making decisions off of it, right? So thank you guys for allowing me to go off on that fun tangent of mine, tree height and everything that you can sort of see from it. To Mike, to your point about what we can see from this with this laser data, I want to really emphasize the point that we're always making trade-offs with remote sensing. And one measurement will give us one insight. Another measurement will give us another insight. And all of these ways of seeing the landscape and seeing a phenomena is what allows us to have that understanding. And so, just like every person has a different way of seeing things, the sensors have kind of the same thing too. And we're entering this wonderful phase where we're doing data fusion, where we are combining together Landsat data together with the JEDI data or the radar data to get better insights and overcome the limitations that one thing has. So, that's kind of thinking about future directions for all of us. It is this, how do these different sensors provide insights together, and that this sensor fusion that is the exciting next step in science for us to do together.
Thank you.
Hey, Peter. Yep. Hey, Peter, one more thing, one more question, and then we'll pass it over to Peter Falcon and the Eyes on the Earth. But first, a statement, this is from Anna. She says, the fire seasons in Africa coincide with South America, but the extent of the fires appears to be greater, even greater than in the Amazon. Her questions are, is it known why they are bigger fires, Does it have to do with the management of the fire if they try to put it out right away, or other aspects that you may know of?
Yeah, so Anna, you're exactly right. It really goes back to sort of the management. Some of this is exactly the same sort of illegal logging as what, the challenge in the Amazonia area. And so, the early warning of fires occurring, being able to use the high resolution imagery to understand why are those things happening, are exactly the same issues. It's exactly the same sort of thing. And in many cases being resourced and therefore not being able to deal with it. And so there's the people aspect of it. But then there is also the natural lightning strikes and sort of the natural rain patterns and processes that happen there that just cause big biomass combustion, and this kind of goes back that there's a lot of rain that causes a lot of growth that then can get burned in those dry seasons. And so I think it's just this this interesting cycle that is occurring. But you're right, Anna. I don't know exactly why some of those fires end up getting so big, right? Is that purposeful? Is that a lack of ability to put them out, to sort of fight them? Those all, I think, kind of goes back to looking at some specific examples and really drilling into what is happening around these areas. A lot of the natural areas that are protected also are burned, in kind of that periodic way. And so again, those protected areas might just be bigger than they are in Argentina and the Andes area. Again, just, because of the size of it. So you're exactly right. Some of these things are preventable. And there are groups that are trying to provide incentives so that maybe that biomass or the carbon doesn't get burned. It actually stays and gets stored there. I think these are some of the exciting things that are kind of coming down the line in the next 5-10 years, to try to deal with the explosive carbon, literally that is coming. And important. I think this has been demonstrated over and over and over again. NASA really likes these visuals of the sandstorms coming off of Africa that end up seeding the hurricanes and then end up becoming the impacts that most people in the GLOBE program tend to focus on. And at the same time, all of those fires are doing similar sort of things. They're putting particulates into the atmosphere in a different way. And so I think, how those two big inputs into the atmospheric system are going to impact humans, or what people are doing in the United States and how they're responding to hurricanes and that kind of thing. I think it is a bigger conversation that the GLOBE program could be actually fostering a little bit more. And these global connections and what is happening and how people are responding and maybe trying to deal with deforestation in Africa, how are they impacting the hurricanes and how people are responding in the United States to plan for those events. And so Anna, you really demonstrated the need for us as a GLOBE community to be having these conversations about those connections like that. They're big, they're hard, they're complex. And so it's not easy, but I think this community is well positioned to be talking about that, and importantly, providing the information that will help us to understand how we're connected in this way, in the way that you talked about, and what are the similarities, right? Same issues, same questions, but then also what are those differences? So thank you, Anna. You really set us up for, I think, what we'll be able to talk about a little bit more in that January conversation about why NASA wanted and needed to map out every tree in that sub-Saharan Africa area. And it gets back to, if we don't have the data, we can't make decisions and we can't understand our processes. So yeah, and I'm glad that you responded well to that. And I think, you know, this is hopefully getting the data out there will get us as a community really talking, so that it's not just one person, Peter, leading the conversation, but other people are coming in and helping us to understand what is happening and how we can work together as a global community.
You know, Peter, before I pass it over to Peter Falcon, you know, one thing that I had in there in the agenda, you know, as part of the group discussion, and, you know, I want to touch on that now for a second, that, you know, as our team, Peter and I were, you know, planning this webinar, you know, we were talking about, and what Peter just mentioned, that's why I'm thinking about it, you know, all the data that we need to understand a place is just, it's kind of never ending. You know, and for instance, you know, we were talking about the, you know, the 2015, the Globe expedition to, I guess it the research expedition. So we were talking about it in the sense of, I'm trying to think, you know, the Kilimanjaro expedition, in the sense of, you know, there was lots of data taken there. You know, there was everything, you know, globe protocol data from air temperature, clouds, surface temperature, relative humidity, soil temperature, and a bunch of other ones having to do with the water that they found on the mountain, from pH, electrical conductivity, dissolved oxygen, all of the above. But, you know, one thing we were talking about, that's a lot of data, but, you know, two things. Was that enough data for us to really understand that environment? And were there some, you know, missed opportunities in the sense of, you know, where did anybody do the land cover data there? Did they do any of the tree height data? And things like that. So I don't know, Peter, if you want to talk a little bit about that, but that's one thing that we like to focus on when we're talking about, when you're looking at like these maps of, you know, of Africa for land cover, and then, you know, the tree heights in these areas, you know, those are just two variables, although they can tell us a lot, you know, and then we can add these different environmental variables to it. You know, when is it enough data? And, you know, in my opinion, I'm going to say never. It's never enough data, because things are changing so dynamically, you know, all the time. So Peter, I see you brought something up here. So yeah, go ahead.
So, you know, so this is Kilimanjaro, right? And so, you know, this is the 2019 land cover. And so, you know, what has brought me to the GLOBE program from the very beginning is this question of how are things changing over time? And so, you know, if we think about, you know, here's what it's sort of mapped out today. But I do know, you know, that it was the, you know, 2015 that there was a big, you know, push. There was a lot of focus on this particular area. Right. And so there should be this never-ending question of how has this changed since then? And did we as a GLOBE community actually record the things that were meaningful? And I go back, land cover is the foundation for everything that we do, unless even with clouds, I'd say it's connected to the clouds. And so, you know, the nice thing is, at least with this, is that we, you know, because of the data, we can at least go back to 2016, 2015 time period and look at what has actually happened between that time when Tony Murphy got out there and, you know, and showed us, you know, how we can do an elevational transect across this area to try to track what is there now and also understand what might be happening in the future, kind of that future scenario. So I really want to kind of put it out there because, you know, here, you know, NASA and researchers are spending their time actually mapping these things out on a yearly basis like this. We're moving to the point where we might be able to even get to seasonal differences. But, you know, when I look at this, you know, there are just, you know, some questions that come up in terms of, has this forest line changed? Has it gone up over the last couple of years? You know, one of the things that really comes out to me is this glacier at the top. How has that changed over even just the last couple of years since we were there? And so, you know, I just go back to this GLOBE database and, you know, and look at what is the data that we have, you know, across all 20 years in the GLOBE program, right? And you know, I look and I go, well, where is Kilimanjaro, or where is, you know, this? So when I look back and try to understand just this very simple question about how has this landscape changed since the GLOBE expedition to Kilimanjaro, I find that we don't have a lot of data. We don't have a lot of information to be able to answer this question. I want to just keep putting it out there, you know, to us as a GLOBE community. Can we increase our data density, collect the right type of information that we can actually help to answer this question of how is the trees changing in response to climate change? How are the glaciers changing in response to climate change, right? All of those things have wide-ranging effects downstream or down mountain. And these are the things that we're sort of dealing with right now. And since we don't have information, we're having to go to less robust information, which might not have the actual story about what's happening on the landscape in the way that we need it. So as you know, as we highlight the different patterns and processes that we see around the globe with the trees, you know, really think about this data in your own personal context, in your own region, in your own area, because this is the data that is being used to make decisions and to understand extents of urbanization, to try to make decisions into the future. So, you know, this is, I think, both the opportunity that we have, but also the missed opportunity if we look backwards in time. You know, what were some of those things that we wish that we would have been able to, or we wish we would have monitored here on this expedition that maybe we didn't, and maybe we can do that moving forward, right? So I wanted to kind of tie these two things together, because there's opportunities that when we come together as a GLOBE community to really leave behind a good digital footprint that helps, say, this local community have the data and information they need to be able to make the choices and make the decisions they need to. And so, you know, I think that there are these great opportunities to come together and help communities that need it, as well as help our own communities to gather that data that we need. Because scientists have been doing it, and they have their predictions. And the key is, you know, let's make sure that we as a community also have information and data that can help us answer those questions, and not just rely on other people to provide that for us.
Peter, Anna mentioned, she asked in the land cover viewer about the coverage map when we have a year. Is it showing, is that the average of that year?
Yeah. So that is a really important one, because when we're looking at, say, these land cover maps, they are doing a yearly snapshot. This is what it is kind of at this point in time. And we're now able to move, because of the Sentinel-2 and some of that new sensors, we are able to get towards more the seasonal cycles that are happening, and maybe the changes in seasonality that are occurring. But for the most part, you know, when we're thinking about land cover change, we're really tend to be on a yearly cycle. We might get to a decadal cycle, but for the most part, we might be thinking about a yearly cycle on these with a lot of these. So, but it is important to pay attention to that map and pay attention to the data that they use to make the map. And that all kind of goes back to you know, understanding that these are predictions, and it's a prediction at a location, and so there's a hypothesis here. We have a hypothesis that this is urban, or we have a hypothesis that this is forested cover. And So use that as a way of going into this and gather some other evidence to either accept that this map is right in this location, or have the evidence to be able to refute that and say it's not correct in this location. And here's why. Here's my evidence. So yeah, that's a really important one, Anna, to really consider is that timestamp of the date.
Excellent, thank you, Peter. So yeah, great, amazing stuff from Peter as usual. I know a lot of you could listen to Peter all day because he always has some great answers to questions that would most likely stump most people. So, but yeah, so you can tell Peter's extremely dedicated to the work he does. So with that said, since we are in the Globe Africa region, I'm going to pass it over to Peter Falcon, and he's going to introduce you, if you haven't seen it yet, to NASA Eyes on the Earth. So let me go ahead and pass it over to Peter, and then we will finish up with a teaser to next week's webinar. So Peter Falcon, take it away.
Excellent. Thank you, Ryan. A couple of things that I really enjoy about Peder Nelson is, first off, his enthusiasm. I mean, that is, he's so energetic. It's it just comes out. Two, every time I think I know something about a subject, I hear him speak and I realize I don't know. There's so much more to learn. And three, just the amount of communication you drive in the chat box. Questions just pop out like crazy. So I think that's great. So I always enjoy hearing you talk just for those three reasons. So what we're going to do now is, very quickly, we're going to talk about slash and burn agriculture and carbon monoxide. So for those that have come to our webinars in the past, know that we try really hard to introduce you to new applications, new resources to help you with your research, help you with your understanding about certain subjects. We talked about the Copernicus data in the past, Earth Engine, land cover, and we've also talked about the Eyes on Earth application. So today what we're going to do is kind of focus in on the carbon monoxide data and the relationship between carbon monoxide and slash and burn agriculture. So if you're not familiar with slash and burn agriculture, you may have heard it under its other names: window agriculture, shifting cultivation, fire farming. This is a process that's been going on for well over 12,000 years. Pretty much anywhere where there's agriculture being harvested throughout the world, we've used slash and burn agriculture. And basically what that is tribal communities, farmers in these areas, will go out and basically burn their fields, burn neighboring grasslands, forests, in order to kind of reinvigorate the land, add more nutrients in it. They usually do this right before rainfall so that the ash and the water can help to produce more nutrients in the soil, help it become more fertile, and then adding an extra yield of crops for them. So of course they do this so that they can provide for the families, and also, more importantly, so that they can feed their families. On a small scale, this is sustainable, but on a large scale, when we see industrial agriculture, that's when we really see the large problems like we've been seeing in the Amazon. And it takes about 2 to 5 years for a plot of land to kind of come back to where it originally was, and where that farmer could then kind of put it back in its cycle as it go back from plot A to plot B to plot C. Well, actually, between 2 to 5 years, then the land becomes degraded and it becomes depleted. And then about 5 to 20 years, it will kind of come back to its natural state. And then they can kind of put that back into the cycle. So what we're going to do is we're going to talk about the Africa region. In Africa, in Central Africa, as Peter mentioned earlier, it's about May, August timeframe is when the fire burning season occurs. So using Eyes on Earth, we're going to go there, get a subset of data, and kind of see where that happens when that carbon monoxide goes up in the atmosphere, and whether it just stays there or whether it actually goes around the globe. So let me go ahead and share my screen. I realize you're just looking at me. Let me see. There we go. My messy desktop. That looks rather odd, but can you see the Eyes on Earth application? Let me see if I do this better.
Yeah, we can see it, Peter.
Perfect. Excellent, thank you. So let me ahead and move my screen here. Get that out of the way. So in Africa, in 2019, there was an article written by some NASA researchers, and they actually dubbed Africa the fire continent. And they did this because they found that roughly 70% of the world's fires in the month of August come from Africa. So in a given day in August, about 10,000 fires are burnt, and 70% of that comes from Africa. So let's go ahead and go to that region, and we'll turn on our carbon monoxide data. We're going to go up here, pick carbon monoxide. And what we're going to do is we're going to go ahead and pick some dates. So I will pick the month of, let's just say July. One of the limitations of this data is you can only get about 90 days. So you can't get a whole year, but we can get a good amount. So let's go ahead and submit that date. And now here we go. We can see the red coloration is carbon monoxide. Well, actually, it's all carbon monoxide, but red on the right there, you can see the higher content. So red is a lot more compared to green, which is more like a baseline, and purple would be less. So as we see the carbon monoxide being burnt here in Central Africa, as Peter mentioned, in Gabon, Congo, we can actually see all that carbon monoxide at about 18,000 feet in the atmosphere as it's being produced, and we can see it as it's going across as well. Anne had mentioned in South America, we see a lot of that as well. And Peter had talked about, the logging. It's also due to industrial crops being produced as well, the slash and burning of large areas. And now as we get into August, we can see quite a large amount of carbon monoxide in the atmosphere. Now, it does have some, slash and burn agriculture does have some advantages and disadvantages. For advantages, of course, that farmer will be able to have that extra yield of crop. It will have short-term soil fertilization. But the disadvantages are far and few. There's so much more disadvantages as far as respiratory problems, air quality, poor air pollution as well, with both young and older people. It hits them the most, including people with asthma. We can see the global impact, obviously, of the carbon monoxide as it's being burnt, and also the degradation of the forest, perhaps also animal species and plant life being lost as well as the forests are being cleared for agriculture. And of course, erosion is a big deal, and in different parts of the world. So we just wanted to give you this tidbit about carbon monoxide and slash and burn agriculture. There's a lot of articles out there on this. So if anyone is interested, you can use those articles, use that research, but also kind of be able to use satellite imagery like the Aqua instrument here, using Eyes on Earth, but also using the other resources that we talked about in the past, like Copernicus, like Earth Engine, to be able to kind of delve into slash and burn agriculture and talk about the carbon monoxide with your students and teachers. So with that tidbit, I'm going to go ahead and turn it over back to Brian. I apologize for going very quickly, but I know we're short in time. But I will put my email and information in the chat box. If you have any questions, you can always email me at any time. Okay, so with that, I'm going to stop sharing, Brian, and turn it back over to you.
Awesome. Thank you, Peter. Yeah, the NASA Eyes on the Earth is such a great resource. It's a downloadable, basically an app that you can, check out so many different data sets and, visually on, with that, looking at NASA data. So, what Peter showed is great. And there's tons of other stuff you can take a look at. It's really good. It's really, really an awesome tool to take a look at, and visualize a lot of the NASA data. So with that said, I'm going to share my screen quickly once again, and I'm going to show you a little teaser about next week's webinar. And it's actually, the presentation is going to be from a pretty prestigious NASA scientist. His name is Dr. Compton Tucker, and he is an earth scientist. I'm not sure if he's emeritus yet, but he is at Goddard Space Flight Center in Greenbelt, Maryland, and he has traveled, to the four corners of the earth and has done research everywhere throughout his esteemed career. And he agreed to, he and his colleague agreed to present, and his colleague is in Copenhagen. So we're going to have the webinar is going to be a little earlier, but let me go ahead and share this here. So the next Trees Around the Globe Student Research Campaign is looking at trees across Africa with a special presentation on the unexpectedly large count of trees in the Western African Sahara and Sahel. And this is going to be on Tuesday, January 11th, 2022, already 2022, coming up fast, at 11 a.m. Eastern Standard Time or 4 p.m. UTC. And they're going to talk all about their research that they did. And what you're seeing here in this image in the background, these are the number counts of the trees that they didn't expect to see in these locations, okay? So you can see they're in the hundreds to thousands of trees that they found. So I'm gonna show you this brief video, and then at the end of this, and then the video, we will end the webinar for today because I know we are over a bit, but you know, thank you all for staying here with us because I know the information that we provide is so amazingly interesting, and I can see, you know, the interest in everyone with all the chat information, the chat questions and, you know, comments and discussion that we've been having. So let me go ahead and share this very brief video as a teaser to next month's webinar.
Scientists. Oh, share your screen, Brian.
This is Goddard's.
What? It's not sharing?
Yep.
Okay, strange. That's odd. It was sharing, and then when I went to hit the video, it said not sharing. Okay, here we go. All right, that was very odd. Let me do this again so you can see this information again. So here is the information, the shareable for the webinar. Okay, let me go to the video now. Sorry about that, that was odd.
Scientists from NASA's Goddard Space Flight Center, along with their international collaborators, have demonstrated a new method for mapping the location and size of trees growing outside of forests. The big surprise? They discovered an unexpectedly high number of trees in semi-arid regions, often thought of as too dry to support plant life. Mapping non-forest trees with this level of precision was previously impossible across broad areas. This technology represents a breakthrough for mapping and measuring these trees. Using powerful supercomputers and machine learning algorithms, the team mapped the crown size, which is the width of a tree when viewed from above, of more than 1.8 billion trees across an area of more than 500,000 square miles. This study is the first in a series whose goal is not only to map non-forest trees across a wide area, but also to calculate how much carbon they store, vital information for understanding the carbon cycle and how it's changing over time.